2023 was a year of many significant events, not just in science but also in politics and climate. While some of these events were not pleasant, there were also many exciting announcements from various government agencies and scientific communities. One of the most notable discoveries was the room temperature superconductor, which was later found to be flawed science. Additionally, there were some intriguing stories about UFOs and aliens, including the Mexican aliens, which were later proven to be untrue. The US even held UFO hearings, with NASA joining in to investigate. As we approach the end of 2023, there is one more story to discuss: the concept of the impossible drive, or quantum drive. This mysterious engine is able to produce propulsion without any fuel, and while it may not be scientifically sound, it is still fascinating to investigate. As we know, refers to an object's tendency to remain in motion or at rest unless acted upon by an external force. Newton's mathematical explanation of inertia is well known. However, it is worth noting that this proposition may contain a few errors. So, let's explore the idea of quantized inertia once again and delve into the physical presence of the quantum drive in space. The objects begin to move and will continue to do so unless acted upon by an external force. While TAN physics can describe inertia in terms of action and the effects on objects, it does not provide an explanation for why it occurs. What prevents an object from moving on its own? In contrast, the concept of quantized inertia attempts to bridge the gap between relativistic and quantum theories and provide a more comprehensive explanation for Newtonian physics. It is often said that the concept of the event horizon around black holes is quite logical. Essentially, it is the point of no return where nothing can escape, resulting in the blackness of the black hole. However, there is an exception to this rule known as the Hawking radiation, which is believed to be produced around the black hole due to quantum physics. This radiation is created when a particle-antiparticle pair is formed and one of the particles escapes while the other falls into the black hole. This process results in the production of actual radiation and also takes away a small amount of mass from the black hole. The existence of Hawking radiation has been experimentally proven in a natural environment by utilizing different analog black holes. The image provided is actually a result of a study that employed analog sound black holes, which successfully generated Hawking radiation. This particular subject matter was previously discussed in one of the videos located in that specific area. Consequently, the presence of black hole event horizon and Hawking radiation has been highly likely substantiated through the use of various analog methods. However, it is worth noting that something remarkably similar occurs all around us at the boundaries of the observable universe. This occurrence is a result of the universe's significant expansion, where objects near the edge expand at a rate exceeding the speed of light. Consequently, a different type of horizon is formed, although it is not referred to as the event horizon. The phenomenon known as the Rindler Horizon is a concept that exists throughout the universe. It can be considered as the actual event horizon of the universe to some extent. Let's consider a scenario where we are accelerating towards a single point in a three-dimensional sphere, moving in one direction. As we traverse through this sphere, we will observe a shift in the Rindler horizon. In other words, the sphere itself will undergo a shifting process. Due to our acceleration, the Rindler horizon will also shift accordingly. If we accelerate at a slower rate, the Rindler horizon expands. Conversely, if we come to a stop, it returns to its original position. Maka provides a comprehensive explanation of this concept. In essence, the event horizon moves as we accelerate in a specific direction. However, similar to the phenomenon observed in black holes, this event horizon possesses its own unique radiation known as the Unruh effect, or Unruh radiation. The proposition here is that as you accelerate in a specific direction, you will encounter an increased number of these particles colliding with you due to the Unruh radiation. Essentially, this concept is akin to the occurrence of particle-antiparticle pairs, or the well-known Hawking radiation. In simpler terms, as you accelerate in a particular direction, you will inevitably experience a greater influx of radiation originating from the universe itself, specifically from its horizon. This phenomenon holds significance in the realms of both quantum physics and relativistic physics. The sound it produces seems plausible, although it lacks concrete evidence. But at present, our understanding remains limited. However, based on this principle, MCO suggests that inertia may be attributed to the opposing force exerted by Unruh radiation when an object is pushed. Consequently, if the object accelerates due to the pressure from radiation, it must continuously employ propellant to maintain acceleration. This concept, rooted in quantum mechanics and gradation theories, offers a partial explanation for inertia as a tangible physical force. When presented with this explanation, it tends to astound and clarify for many individuals. However, there are a few predicaments that arise. Firstly, from a physics standpoint, the force of inertia is believed to be exceedingly feeble, almost imperceptible. To even detect a slight variation or experience the slightest hint of radiation, one would need to generate accelerations of astronomical proportions, comparable only to the movements of atoms. Consequently, attempting to substantiate this concept experimentally has proven to be nearly impossible. As a result, most scientists do not consider it a viable explanation for inertia. Secondly, a more pressing issue emerged when, in 2019, someone discovered mathematical errors in the original proposal. Since they have not been addressed since, it is uncertain whether the quantized inertia principle, despite its intriguing and distinctive nature, could potentially be a miscalculation or a mathematical error. Interestingly, they have conducted a few experiments, although not specifically focused on discovering new radiation. Instead, these experiments were based on certain propositions within their theory. One such proposition suggests that, similar to the EM drive, it is possible to utilize this inertia to generate physical propulsion within a specific shape solely through the use of electricity. In other words, it is possible to create a propulsionless drive, commonly known as the impossible drive, or in this case, the quantum drive. A few years ago, Mull received a grant from DARPA to investigate this concept, despite initial doubts about its feasibility based on physics. However, they proceeded with physical experiments, and some of them showed potential positive results in terms of producing propulsion. However, as we have learned from the video on the EM drive, these positive results can sometimes be attributed to bias or mechanical issues. Similar to the problem discovered with the EM drive, there are uncertainties surrounding the quantum drive. Honestly, the information available is quite limited, but it seems that a US company attempted to test it and may have found positive results. They decided to send it to space via a SpaceX rocket instead of just conducting lab tests. IO Limited and Rogue Space Systems collaborated on the project, which involved a CubeSat containing a new quantum drive engine. The company has kept the specifics of the engine under wraps, making it a patent. If the IA quantum drive works, it would be a groundbreaking discovery, but if it doesn't, it would just be another year of unusual science in 2023. In 2023, a year filled with peculiar scientific occurrences, this satellite has recently become active in space and is now preparing for a relatively lengthy experiment. The experiment itself is quite simple, as it involves activating the engine using only electricity. If all goes according to plan, the satellite will utilize the effect of quantized inertia to obtain a small amount of propulsion. The magnitude of this propulsion is expected to be equivalent to that of the EM drive. Remarkably, each unit of electricity is anticipated to generate 52 million units of thrust, surpassing the efficiency of the widely employed ion engines, known as Hall effect thrusters, utilized in numerous NASA missions. The quantum drive is a game-changer in space exploration, boasting an efficiency increase of 60 to 80% without the need for fuel. Unlike ion engines that require xenon, which can deplete and are cumbersome, this technology runs solely on electricity and weighs only 200 grams. While it holds great promise for scientific breakthroughs, there is a possibility that it may not be based on sound science. Nonetheless, the engineers behind the startup have tested it thoroughly on Earth and are confident in its potential. The researchers made sure that their observations were not influenced by any biases or interferences. They were able to measure thrust accurately, but the cause behind it remains a mystery. Although the experiment was conducted on Earth, if it works in space, it could be a significant breakthrough that could change everything. However, we won't know for sure until 2024. The data collection process alone will take several weeks, and the actual experiment won't begin until then. If the mission is successful, we could be on our way to Mars.
For today's video. What do you think of our video? Feel free to share your thoughts in the comment section below. Don't forget to like and subscribe to our channel for more future updates. Thanks for watching.